Let us look at the forward computation of outputs, and we have considered the example from layer 2, that is this layer, to layer 3. 3 neurons, including a bias neuron, this is the bias neuron in layer 2, and 2 neurons in layer 3. So the layer 2 weights are given here. We have 3 cross 2 because 1, 2, 3 neurons and 2 in the next layer. This is the bias input and the layer 2 outputs. So these are the inputs which are going to the next layer. And we want to compute Z3, which is this Z and Z. This is given by the multiplication of the transpose of the weight matrix with these inputs. So we get these Z values, and to compute the A output values here, there is a one here and here, we pass it through the G function or the activation function at the neuron. Now we look at a solved numerical example on the same setting where we have 3 neurons here, 2 here. So the weight matrix is given like this, 0.5 minus 1. So what is this 0.5? It is this value, and with what is minus 1, it is this value, and so on. And the outputs from layer 2, which are going to the next layer, are these two, 0.4 minus 2. So this one is 0.4, this value here, this is 0.4, and the next one is 0.2, and one is the bias input. So this is the bias input. We want to compute Z3. So simply take the transpose of W, multiply it with A, and we get these values, 0.38 minus 0.86. See, we have 2 neurons, so 2 Z values. Assuming the step function as the activation function with 0 threshold, the value is for the upper neuron activation output here, A value here, comes out to be 1 because we get 0.38, and for the lower one it is 0 because we get the value of Z as minus 0.86. So this is how we do the computation of outputs for between any two layers. We have taken example of layer 2 to layer 3. Thank you.